Hi, my name is Phil Parker, and I'd like to talk to you about a project we've been working on that looks at new approaches to search, those that might actually have a chance at supplanting Google in the long run. We'll start with a hypothetical. Suppose you wanted to create, with absolutely full privacy for the end user, a national search engine that would focus on your country or culture and that would emphasize content that's actually buried by Google at this point. Or maybe create a search engine for your employees so they could easily find business opportunities or things about their value chain. Or maybe a customized search engine for your book club, or maybe your church group, or your elementary school, or a homeschool student with learning difficulties. Or perhaps a search engine biased towards fly fishing, your political point of view, poetry, maybe the abrasives industry or mathematics. Or maybe a search engine where you get to control all the algorithms so that one day you might want to change and look at pasta, or maybe focus on Deadpool or optimistic content, or perhaps conspiracy theories. Or perhaps you'd want to have a time capsule search engine where you could see what the internet looked like in the year 1860 or any year you'd choose. In order to achieve this, what you actually need is an engine that writes search engines in real time, thus allowing the end user the full freedom to prioritize, sort, design, and filter the content that they choose. We'll start with a little background. I'm a professor and entrepreneur at INSEAD, and our team of about 20 engineers focus on automated content engines. We've applied these in numerous organizations and projects around the world, in Latin America, Africa, and Asia, sponsored by organizations such as the Bill and Melinda Gates Foundation and the Grameen Foundation and others. And what we're trying to do is generalize that to all known subject areas and languages. In this video, I'm going to condense a larger presentation covering the strategic and product objectives of this initiative. There are a number of reasons why Google has its strong market position, and there is an equally long list of people, organizations, end users who are not totally satisfied with what Google has to offer. After having come up with an extremely long list of all the factors that could create a differentiated offering, we implemented demonstrations and co-creation workshops with a number of organizations and people. So now we'll be looking at some feedback from end users who have had a chance to see this approach in detail, as well as feedback from potential partners who are thinking of commercializing this technology. It's worth noting before we start that there's been a few international examples where when Google has been challenged by a local organization, there's been some success. In Korea, for example, Naver has done quite well. Yandex to some degree in Russia as well. And even in the small Czech Republic, a local search engine has done quite well against Google. While our engine can output a number of different styles, the most appealing to many people is a simple, cleaned interface with a number of zones that can be actually manipulated. The top zone has ample room for shortcuts, for example, for translation, news, maps or calculators, weather, preferences, and anything that the end user might want to add to that based on their choices. Included in that is the ability to change the interface into any number of languages. Above the search box, you can also see that the slogan or branding can be changed easily. On the bottom, there's an area to select any kind of sharing or social media platforms that you might want to add, or other information that might be useful. While the engine can passively learn people's preferences, we allow people to overwrite those with whatever settings they would like. For example, they may be interested in sharing the search results on certain social platforms, or adding shortcuts to the top, or perhaps changing the geographic emphasis so that search results are more relevant to their local conditions. This localization can take place at the street level, the state level, the region level, or even the national or international level. In addition to geographic preferences, the user can perhaps want to learn a new language, and they can specify additional languages that they would like to add to the interface or that they would like to learn more about. One can also select broad topical categories such as fashion or IT or religion that'll change the engine results. Based on these macro preferences, one can then select micro preferences that are subcategories within the broad preferences that the person has chosen. Returning to the home page, One sees a very clean interface as a default. That can be changed. You type in any keyword you'd like and you get a traditional result. At this point, I'll pause to kind of highlight a few areas that differentiate from Google and others. At the very top, there is a sequence of tabs that are affected by the preferences, either passive or active preferences that the end user decides to set. Below the tabs is a translation ribbon based on the languages that the person had selected in their preferences. And below that is a ribbon of shortcuts to other search engines, followed by a series of blocks that give general search results. The order of the blocks and the type of blocks is a function of the preferences that the person had inputted in the preference settings. These are organized to reduce redundancy and closely fit the user's preferences. Within each block, there's an extension arrow that allows people to get various perspectives on the same block, in this case, many different definitions from very different sources. A major differentiator is the tabs and the tab structures at the top of the search results. These can be manipulated and changed in a variety of ways. For example, suppose I would like to have a translation tab a little bit closer to the beginning of the tab structure. I simply drag and drop it and move it there. Or perhaps there's other tabs I might be interested in. Because I'm interested in literature, I might put a quotations tab at the top bar, or I might add maybe a tab based on lyrics because I'm a songwriter. Again, preferences will determine what the tabs are available to the person to choose from. Here's an example of the tab structure for a fly fisherman. You notice the usual suspects that we find on Google, such as news and images and videos, but you also have fish, flies, rods, reels, insects, and tides. In this case, it's for Newport Beach. By clicking on the Fly Fisherman tab, you get filtered results that are focusing on fly fishing, and on the www tab, an unfiltered look at what the World Wide Web looks like without a fly fishing bias. Here's a search result where someone has chosen to bias the results towards the Philippines. This is a city level tab focusing on Kuala Lumpur. Mathematicians gave us feedback that they wanted to be able to search across equations. This is an example of an equations tab that allows the users to view the results in LaTeX format, MathML format, or its standard HTML functional form. In this example, the person has set their defaults to include computer coding, so it must be an IT manager interested in mathematics with equations, a bit of poetry, but we also see that they're interested in politics. There's two tabs introduced, liberal and conservative, plus they're interested in what's going on in Twitter and Facebook, so we have a tab called Chatter, another tab called News, and next to that is a tab called Fake. Rather than filter out fake news, we've put it into an area where one can simply browse fake news and kind of look at what people are talking about, either accusing something of being fake news or actually satire sites and conspiracy sites and the like, as well as images and videos. The Code tab is nothing more than a search across computer code. The Poetry tab, similarly, search across poetry. The Liberal tab covers query results from liberal sites, and the Conservative tab covers those from conservative sites. Users told us that they wanted to have control over the searching and sorting algorithms, so in many tabs, such as the News tab, we allow people to actually change the sort order dynamically in real time. For example, in politics, you can simply dial up the level of left versus right-leaning news sources and then immediately see what the difference of the search results might be, starting from libertarian on the far right, going over to perhaps conservative or moderate towards the middle, and then going a little bit farther over to the progressive sites or the socialist leaning news sites, allowing the users to see the difference for the same search string, such as Trump, the difference that exists in the internet. Beyond that, there is also many other sort criteria, such as the year in which the results came from, the attitude, negative versus positive, how exaggerated use of adjectives and adverbs, exaggerated versus factual, the gender focus, male, female, whether it's an impersonal or a very personal news articles, or ones that are highly quantitative with facts and figures versus those that are more general, speculative, that have exaggerations and the like, or the degree to which a site might have vulgarity or not. All things people can use to sort the results. One of my personal favorites is your ability to choose a year. What would the internet have looked like, for example, in the year 1863? By choosing this function, one can then, with this slider, see what articles might have appeared, for example, with the keywords 407 years ago, and one finds the Chicago Tribune, a reprinting of Lincoln's famous speech at Gettysburg. This is a good example of content that's been buried in traditional search algorithms. Summarizing, this project's been about creating an engine that helps end users write their own customized search engines. We're guaranteeing full privacy by simply not having any tracking or log files saved anywhere on the system. All preferences are saved as an encrypted cookie on the user's machine, and it is unique. The user has a lot of flexibility in choosing and prioritizing the interface by geography, by language, by subjects and microtopics, and various tabs sorting and filtering as they would choose. In essence, we've come up with an idea of decentralizing search content decisions to end users or countries or organizations that want to launch their own search engines. In the second part of this video, I'd like to highlight commands and edge cases, some query issues and translation issues that come up during a due diligence phase of companies or organizations that are thinking of commercializing this technology. The engine includes thousands of commands. These are typically queries where a user wants information back, not links to websites that have information necessarily. For example, if I type in the word time, San Diego, you'd like the time in San Diego, etc. There are many domains, and we've created literally thousands of different commands across all topic areas, responding to users' preferences. A few examples include someone asking for what time it is in any geographic location. If one types in synonyms love, for example, a thesaurus appears, and that thesaurus includes various synonyms by parts of speech and by context, as well as antonyms of the word. Because the person may have selected in their preferences non-English languages, a thesaurus exists as well that's bilingual, that translates between English, in this case Amharic. The word numerology is also a command with any string. The numerology block reduces the word to a numeral or pair of numerals, and one can look up all the different schools of thought related to that and or translate those words into any language chosen. An interesting edge case is when one types an extremely large number, the engine returns various conversions and calculations that are likely to be needed by the user. This is sorted by their preferences. In this case, this person was interested in finance, so exchange rates appeared first. As with many of our commands, when we contrast this to Google, we find out for the same entry, simply no results are found. Another edge case example is the case when someone types in a pair of two words, 45.4 and 26.1. It gives you various information. In this case, mathematics shows up first with a chi-square distribution, and later there's a longitude and latitude. Note that if you change that query and simply add one extra digit to one of those numbers, for example, adding a 2 before the 6.1, this is no longer can be a longitude and latitude, and the engine therefore outputs information that's only mathematical in nature with no reference to geography. The same results in Google lead to rather obscure and mostly irrelevant sites that happen to have those two numbers. Such results show lower on the page for our engine. The word macromolecule is an example of a command. It yields pictures of macromolecules related to cancer or the string, as well as information about those macromolecules. And within each result, you can see the branching to other chemical compounds and the like. Contrasting with Google, there are no pictures of macromolecules, only articles that have the words macromolecule and cancer, nor any profiles of those or molecules. Even when you go to the images, there are simply no images of macromolecules relating to cancer. Rather, these are images of articles that mention macromolecules and the word cancer. Domain names themselves can be commands. In this case, I typed in INSEAD with private equity, and it gives a #1 link, but you can actually do a deep dive within the website and get all related links with private equity and INSEAD combined. In contrast, Google only gives 3 links that allow you to actually see content related to the subject within the INSEAD site. These are just a few examples of how commands work in the engine. Non-command queries are handled in a very similar way. We note here that about 45% of queries are single-word queries in most mobile and fixed applications. 20% are two-word queries, 15% are three-word queries. The engine treats each of these quite differently depending on the context desired and or the preferences setting, generating the optimal page based on the query that comes in and the number and types of words that are actually used. While there are many query types, for illustrative purposes, I'll only be discussing 2 types for simplicity: navigation queries and translation queries. To differentiate on navigation queries, we engineered to three types of queries. One where the top level domain name is typed, the second where it is not, and the third where people tend to use a shortcut. Two types of people exist. The first is the pop segment. These are casual users who want to navigate to a website, and the others are professionals, and we designed for them as well. In Google, if you type in gym.com, you'll end up getting only one link that's actually relevant, and that's to the pop segment. All of the other links, no matter how far you go, are typically irrelevant, and this is true for millions of sites. In contrast, typing the same query in our project leads to similar results, mostly focusing on the pop segment to begin with, but many more links, including a directory to the website. After that, tools are actually presented available to the professional, such as perhaps a bubble diagram, and they can customize it to anything they want. Marketers would like this kind of a thing in a PowerPoint presentation. If they don't like bubble charts, they can select cloud-based diagrams, word clouds, and also customize these, their orientation, the font, the language, etc. Additional tools include the linkages within the site itself, but also for linguistic purposes, for search engine optimization and other reasons, the entire linguistic map of the web page concerned, including its translations and frequencies across multiple languages. As one scrolls down the page, the results are much more professional in nature, including a sitemap and things that DevOps teams, security teams would be more interested in observing with respect to this particular website, gym.com. For people who have made a mistake in typing, eventually you get similar websites, or for people who want to look at competitive domains that may not have been reserved already, you end up getting a list there. At the end of the day, the outbound links are going to things that are useful for those segments, such as traffic, security observations, the degree to which the speed of the website is high or low, maybe some older versions of the website, and or its official registration information, etc. Of the informational queries, probably the most vexing are the translations, so we're going to spend a bit of time on this. For many domains, especially internationally, this turns out to be the most dominant query amongst searches for single words, phrases, idioms, and the like. This chart illustrates well that in countries like Japan, Germany, the number one query in Japanese, for example, is the word translation, and this is common internationally. These numbers do not necessarily reflect, however, the intensity of how important this query is. In France, for example, about 38% of queries coming into Google are about translation. The number one word, traduction, in fact, is ranked highest, and it's been typed in various different ways. This is very common, and even in places like Hungary, over 50% of the related queries are coming in for the purpose of translation. For this reason, if you're not focusing on translations, you're not really going to be able to focus on search very effectively. If you take the top 1,000 queries, what you discover is that virtually all of them are just single words. However, if you take all queries that typically go to a translation system, you're looking at mostly two-word phrases, sometimes 3, 4, and 5. Rarely, only professionals really go beyond 5 words when they're doing an online translation. What we've decided to do is have an optimal linguistic translation for each level of word use, be it 1 word, 2 word, 3 word, or beyond. To do so, we focused on allowing for multiple perspectives, whether popular or professional levels of translation, idiomatic variances, knowledge acquisition, trying to discover errors and outliers, and then focus on excellent at every level of words that are being inputted into the system. This required substantial investments in language depth. For example, we have over twice the number of records for the French language, amongst others, than we were able to determine from Google. We detect well over 600 different languages as opposed to 103 for Google, and we have multiple methodologies for the same translation, leading to a hybrid and blended methodologies across different translation engine settings. Let's look at a few examples from Google. The first one is the word dog, and what you'll notice on the left side is a few definitions for that word. In the field of engineering, if you scroll down far enough, you'll notice that there is a definition related to an engineering use of the word. On the right-hand side, however, you'll notice there is no translation for that usage of that word. In addition, you'll also notice that there's only the masculine form for that word, not the feminine form. For a technical term like glioblastoma, there'll be a definition in English, but there won't be a corresponding definition in French. For a simple two-word expression, Google gives an incorrect translation, and that's true whether you capitalize or you lowercase that first word in the phrase. In addition, perhaps using suggestions from end users, Google often gives completely spurious or wildly incorrect translations for various strings. Or it sometimes detects the wrong language and translates it into a language with an incorrect translation of that word from its origin. Professional users have noticed that many words that are used commonly in a language simply are not found in Google's corpus of words, therefore giving incorrect translations. Finally, some users will be typing in abbreviations, and an abbreviation may come back, but little understanding of what the abbreviation means is returned. Alright, so let's start with a single word translation for dog. And what's returned is a very particular format. First of all, it ranks orders the translations by their probability of being correct. It starts with the masculine chien, then the feminine chien, and then a little bit of slang and jargon after that. In addition, you'll notice that there are these various robots covering different translation philosophies, idioms, gurus, abbreviations, and the like. These are used to allow people to see within context what translations are about. For example, the word hound. That gives a different type of translation probability based on the usage of that. You go a little bit farther and you notice that there'll be the engineering context of a latch, and that's actually given, again, the top most probable translations for that word. Idiomatically as well, there's different ways to look at this word, dog, rose, etc. If you want to have knowledge on the word dog, then of course you can actually read it in French what a dog is all about, not just the canine, but also the mathematical use of the word when we're talking about differences in Gaussian functions. Also, we look at abbreviations, degré de gloire, but also engineering definitions, etc., so one can see all of the facets of what dog might mean. A little bit lower gives you all the synonyms associated with the word dog in English and then back translated into the other language. You take the back translation from the language into English as well, including expressions of the use of the word dog, the most common ones found in the literature or in writing. In addition to that, there's the back translation of the expressions of the word chien going back into English, so people can understand the variances and the subtleties of the word. An entire thesaurus is then offered, which gives the translations and the synonyms by part of speech, noun, verb, adjective, and other forms of expression. But in addition to that, it also gives synonyms with respect to a context, for example, in an animal context, as a distraction, as in heat, etc., or antonyms. In addition, a little bit of wisdom. Where is the word dog actually used in the literature in that target language? For glioblastoma, as another example, the guru functions become quite useful because people might not know what that word means in their domestic language, and so the gurus provide a little bit of extra information, whether it's used in one context or another. Using a bit of graph theory, we're able to get the correct translations of a word in addition to its use in expressions and or its definition. Using a much larger corpus of words, we're able to translate rather obscure terms into the target language as well, and provide a small glossary at the bottom to give alternative translations. And for abbreviation, the engine actually produces a number of translations for that abbreviation, but also explains what that abbreviation means in the target language, giving a little bit more understanding about what that word and phrase means. For example, in the area of zoology, GMO might stand for golden masked owl. Finally, an interesting aspect of our methodologies is often it will give a bit more context. Always be closing is of course translated, but there's a little bit more knowledge that might be available, and it shows that it was probably used in a film called Glengarry. And in addition, by looking at definitions that might have been used for this phrase, we understand it has to do with sales and salesman approaches. Well, discussions with partners has typically been more in depth in this video. It should give you a broad idea of the notion of what this project is all about. If you are interested, please feel free to reach out to me. I'd be glad to hear from you. Bye-bye.